And so I'll follow up with this being sort of the first presentation after lunch with a piece of trivia. We just discussed for Germany, 17th of June was a very important date, prior to 1989 at least. In 1953, there was a big uprising in Eastern Germany against the then East German socialist government. And that was then sort of the first impetus for reunification. Was put down with the help of course, the Soviet troops at the time. And then they proceeded to build the wall, and then the next unrest was in 1989, and that was a lot more successful back then. So here's that was my piece of trivia from the German perspective on June 17th. But coming back to automotive industry, first of all, maybe introduce ourselves. So Jorg Schulte. I'm with BMW, obviously, based in South Carolina in our plants in Spartanburg. The manager of the Research and Innovation Liaison Office, as it's called. So I'm basically doing all sorts of things that are looking at future projects and improvements to the plant. I work with companies and also with our academic partners in the area.
Thanks, Jorg. My name is Percy. I'm COO of the company Ubimax. First of all, I want to apologize for all of you that Hendrik Witt cannot be here today. He has some ear problems, so he could not fly, so I'm stepping in for him. And but everything you wanted to talk with him about, you can also talk with me. So at Ubimax, I fulfill the COO role. So I keep the processes running. I make sure that everything runs smoothly within our company. And as Ubimax, we make sure that your companies run smoothly as well with wearable computing. We're focusing a lot on the logistics industry, manufacturing, quality assurance. That's what we're going to talk about today. But also going into the maintenance field and remote assistance. So the typical scenario you see around here, we're also dealing with. Having said this, I hand over back to Jorg to start over the presentation.
All right, great. Yeah, and we'll continue to do a little bit of ping pong back and forth here. I think that's hopefully a little bit entertaining for you and then sort of keeps you awake after lunch.
That sounds good.
Yeah. So we'll take you through, of course, a little bit of BMW, not so much the products. I suppose everybody has seen a product around somewhere. But we'll take a little bit of a look at automotive assembly, where these cars are coming from, and then, of course, we'll go into the wearable innovations and the projects that we've done. We'll focus on one particular case study that we did with Ubimax in assembly, and we'll go into quite a bit of detail on what we did there and what the lessons learned were, and of course, then we'll have a discussion afterwards with you folks. So, brought a little video of the plant. So this is Plant Spartanburg. It's 21 years old now. Opened in the '94, and it's ever since it was opened, it's gone through a number of iterations in terms of the models that were being built there. The structure have been adapted accordingly. Over the years, it has been expanded to 5.6 million square feet total sort of covered area. The investment was, I think, around $7 billion up to this point, and just over 8,000 jobs on site at this point in time. And what you see here is a look into the assembly. Assembly is the third stage of an automotive production plant. Typically, you start out with the body in white section, or the body shop, where the metal parts get welded together. Then they move into the paint shop, get painted and surface protected. And then they move into the assembly, where the metal parts, the metal body gets completed into a complete vehicle. Another piece of trivia, actually, while we're at this, the production that BMW is outputting out of this plant, it's 1,400 units every day, makes BMW the largest US automotive exporter in 2015, and actually also in the previous years. So maybe something to keep in mind. The heartbeat, so coming back to the 1400, the heartbeat of this factory is 90 seconds. So every 90 seconds, we have one vehicle coming out of this assembly line. We have another assembly line that also runs at 90 seconds. And then in total makes then the 1400 vehicles and just over 400,000 units per year. But it's really important, of course, to keep this heartbeat going, to have that process basically reverberate throughout all the assembly operations that are taking place, and that sort of propagates then out all the way to the suppliers that are providing parts just in time or just in sequence. So BMW, being a premium manufacturer, put a lot of focus on two things. On customer orientation, for one, which means that most of these vehicles are actually customer specified. So especially in Germany, for example, markets are such that people go to a dealer, they order a vehicle specific to their tastes in terms of the option content, etc., colors. And then they wait until this vehicle is actually delivered. BMW has built the manufacturing system in all the plants based on this model to be able to have fully customer-specified vehicles built on the assembly line. So any of these models that are coming along these 90-second tacts are basically all different. So variability and customer orientation is the one thing, and the other focus is then, of course, quality. And quality is something that has numerous facets, something that we could talk about for quite a long time. It leads to, among other things, to numerous inspection stations that we have throughout the assembly line, and we'll come back to one of those for the case study. So quality is another sort of interesting piece here. This picture that is up here is something that was used by our corporate communications for quite a while, until somebody noticed, that car has a defect. Anybody see it? What's the defect?
The tire's too small.
No. Still has an exhaust, yeah. No, it's the window finisher. Yeah, see that? The window finisher there where that red circle is. So it was missing there at the bottom. So it's one of these things. You look at the vehicle and you think, great, perfect, and then, as I said, so of course this person found this defect for sure, but it took us a while to find it on this picture. So which gives you an idea that really the challenges in automotive is this repetition, this quick repetition. Every 90 seconds you have another vehicle to really fully check, combined with this high variability. Every vehicle is different. And then at the same time, of course, the third one is that all of this needs to happen in a cost-effective way, so the efficiency can't be lost on this, so you can't have an inspector inspecting the work of the previous inspector, etc. So you want to have it done right the first time, and ideally, of course, without any further inspections. So these three challenges is really sort of what's driving a lot of the innovation projects at the plant in order to improve the capabilities towards customer orientation and vehicle quality. Now, for this, there's a number of technologies now that are out there. From my point of view, there are really sort of three big areas that are opening up and hold tremendous potential to support solutions in this towards the challenges that I was mentioning. the analytics with deep learning. These kinds of tools are becoming available. The Internet of Things, the connectivity, everything connected to everything else, and then of course the miniaturization of devices, which allows us to basically now wear something like what used to be the processing power of a PC, now wearable in front of our eyes. And the initial focus, of course, will be the miniaturization of the devices with the connectivity. And that's what we're discussing here and today. Going forward, I think there will be a lot more potential once the analytics piece will also be coming in there. Once the processing power is high enough that we can also have sort of wearable analysis of really what we're looking at. But that's, I guess, the future view. All right, so now we'll focus a little bit more concretely on the wearable devices and more specifically on Google Glass. For various reasons, we have chosen back in 2014 to do pilot studies using Google Glass initially in our analysis center. Analysis center is something, we'll back away from the assembly for a second, we'll come back later on. Analysis center is something that is basically like a repair shop, you can imagine, and it basically deals with all the new vehicles and makes sure that when the initial vehicles, pre-series and test cars, etc., are being built, that all of these vehicles conform to standards, that they perform the functionality the way they're supposed to, etc., etc. So, and then they also used these facilities during production for any in-depth analysis, root cause analysis that can be done quickly in the rework area. And the idea was, with this first use case, to really focus on documentation and then subsequent communication of defects. So the idea would be that an engineer would record a video, for example, or take a picture, and then relay that information back to the engineering departments. And we worked on this with a number of our engineering departments. You can see them there: product audit, first and foremost, then the squeakers and rattle team, functional quality team, etc. And the way we started this project was actually with this sort of, a little bit of a mock-up, I guess at the time we made it. Video showing the functionality.
For the video. Okay, Glass. Take a picture. Okay, Glass. Start documentation. Adam Tony, TS522, September 25th. T-car number 3955. Right front xenon headlight. Design ring, not hoods.
Okay, Glass. Documentation. Corey Benson, TS53, September 26th, 2013. Shifter rattle. So this seems like it's a little bit loose, this shifter, and it makes a plastic noise while shifting. Send to shifter. Okay, Glass. End video. Okay, Glass. Call Katie Jerwitz, TS52.
Hey, Corey.
Hey, Katie. I'm having trouble with this F15 windshield wipers. Can you see it?
Yes, I can. I can also hear it hitting the A-pillar. Which car is it?
It is 7058.
Okay, I'll put in a ticket for it.
Great. Thank you.
You're welcome.
Okay, Glass. End call.
Yeah, so the experience here was that this was sort of the initial idea. Then it very quickly transpired that we wouldn't be able to use the communication function. Had wanted to use our internal Microsoft Link service there, but for various technical reasons that wasn't feasible. And then the user feedback was such that they said, well, glass is kind of okay, but we want to still modify the pictures afterwards. So we built an additional smartphone solution where you could sort of do a markup of pictures that were taken prior to sending them off. Now, this project evolved through a couple of stages, but at the end of the day, we did not pursue this further, since I guess for a number of reasons. Most importantly, the hardware was deemed not really sufficient at this point in time. In particular, the camera quality for our audit folks, for example, was not up to their requirements, along with a few other hardware-related issues, battery life, etc. And then there's also always the internal processes that need to be sort of aligned here. So it was a sort of an interesting and good learning experience and first step for us into this area, but not completely successful at this stage. Since we did this project internally with the development of the app with our IT innovation lab, we thought, well, maybe some of that lack of user acceptance of software can also be attributed to not doing it properly. So that's when we teamed up with Ubimax and said, let's get somebody in here who can do this professionally. And let's see if we can sort of also move to an area that is maybe in more need of a solution than our analysis center colleagues. So at that point, we started out this project on the inspection in assembly together with Ubimax. So inspection, this is a shot of the actual site that we did the pilot at. It's basically on the line in our older assembly hall. It is an inspection station that has the PC. There, the picture on the left, you can see the PC, which sort of faces the assembly line on the other side. So, and the process works such that the associate uses the information from the car, the barcode that is on the vehicle, to pull up the information, what is to inspect it on that particular vehicle. That comes up on the PC display. You can see that on the right. And after the testing, the feedback is reported on that PC. The challenge here is, again, the variability and the repetition. So again, the 90-second takt time, of course, the high variability of the vehicle. So every vehicle is different. And then also this inspection list is not static. This is something that gets updated as, for example, either problems with parts coming in which require additional inspections could add to this list of things. Or some internal issues that were found in final inspection would be propagated to this particular station for additional inspection, etc. So it's something that changes over time. And the big motivation for us was to make sure that the associates doing the inspection really catch all the items that need to be inspected and confirm each one of them individually, and especially for sort of the more exotic options that they may otherwise overlook. So that's, so it's really the walk time back and forth from the PC, but it was mostly really about the accuracy of the inspection, and then also the communication between inspection and rework. that we wanted to improve because there was a lot of back and forth on questioning, well, you reported a defect for this vehicle, I don't find it, can you tell me what it was, etc. Right? That comes back to the problem that with the PC system you only have particular pull-down menus, and you can't really describe things in very detail. So taking a picture is a lot more useful, and picture says 1,000 words in this case. So the project with Ubimax focused on really implementing a solution here to validate the functionality and the business benefits of Google Glass here. Work with the associates to see if they would be open to wearing these things, what the ergonomics were, and then also gather some operational experience and see, what's it like with the battery life, etc.
Thanks, Jorg. So let me now talk a little bit about the Pilot. And we start out showing you a short video so you can see the guy is logging onto the system. He's wearing a Google Glass. So we stuck with the Google Glass knowing there is still some issues with it, of course, but companies are working on that. You can see the guy is moving around the car now. So this is one of the classic examples when it's really, really beneficial to be able to move around freely, and you can see he's grabbing stuff. So having his hands free is key to the process. And you can see he's opening the trunk now, so he's taking a look and using the glass. The glass is guiding him around the vehicle and pointing him to the parts that he needs to pay attention to and do the quality checks. And the good thing is that we were able to do that really in the productive environment. So this is not something that is offline or something that has been done in a safeguarded environment. We really did this on the line in the production to get the insights that BMW needs to have to go further into that direction. And it's also a classic example of where the current technology is really not meeting the requirements of the process. Having an offline PC, I mean, I can imagine I'm doing some work here. The information I need is right on that laptop. It's even maybe further away. And how am I going to not miss any points if it's not a standardized process? Every car is different on the production line, and there's different spots that I need to take a look at. And even for each model, these spots change in terms of what the current findings are from the production, what parts to take a specific look at. So I've lost right from the beginning if I'm going to use a model like that. But if I use wearable technology, I have the information right in front of my eye that I need to do, and then I can freely walk around and do the documentation where I find it. Instead of when I walk back, I've probably forgot most of the parts that I wanted to note down. So let's talk a little bit about the user interface that we picked. And you can see some screenshots here on the right side that we're showing. One of the key things we wanted to do is, in certain instances, it makes sense to check multiple topics at one time because they're located in a small area. So if you're looking for gaps and you're looking for, let's say, the surface of the parts, you may want to do that right in one go. And then, okay, there's these three things you need to take a look at. Okay, I'm going to do that at this point. And then, because the defect is actually the exception, I can confirm that in one go that, okay, these 3 points are okay. In other parts, it may be very essential to get additional information on what needs to be done. And you can see that in the middle picture here, where you see, okay, you have some additional information, you have some picture showing you what to do, you have some indication, okay, it's on the right side of the vehicle. So it's a very easy grabbable information from a visual point of view to guide you to these points. And they can be different, they can change over time. And then when you actually come across some defect that you want to document, you can do that right at that point in time when you find the defect. You don't have to move somewhere else, but you can take a picture right at that point in time when you see the defect. You can select via voice, you can select from a certain amount of error codes the right one, and then you can document the defect right at that point in time. That's very powerful to do that. When we take a look at the, let's say, the facts around the study. So the study was performed from two sides. There was a more academic view by Georgia Tech. So they did the study results and things like that. And there was the part that Ubimax was contributing in terms of the software that we developed. It's important to know that this took place roughly a year ago. So some of the learnings you will see here in the study, I don't think there will be many completely new things that you will see, but it may be some confirmations of what you already know. But some of the learnings that we have already have been implemented in a lot of work that we have been doing, or that BMW has been doing also going forward. So there was 17 people involved with this study. They did these checks on the production line. They had some short introduction on how to do it, and then they were performing the task for about 2 to 3 hours, and then they had a debriefing. So important to know, it's also that an individual gave feedback after 2 or 3 hours of work. So you don't have the, let's say, week-long learning experience here. Study took place 2 weeks, and roughly a year ago that was the case. In terms of the people doing it, and that's something that we believe is very important, is it's really the people that would normally do it. It's no use to pick people that have a master degree in computer science, that have worn Google Glass in their private life for so and so long. But you need to pick people that actually would do the job when they do it. And that's also reflected here. You can see we have a few with a bachelor's degree, but that's about it. Huh? It's not only high school dropouts that maybe you will see a little bit more in screwing things together for the quality assurance. You need to have some kind of knowledge, but it's definitely not the most trained people. And the people that are doing that, you can also see that they really didn't have experience with wearable technology before. So that's something new to them. That's also important to know, realistic environment. And that's what we do in all of our projects. We recommend to really pick an environment that is realistic. Let's go to the feedback. And the feedback, I'm sure there's probably nothing in there that really surprises you. The first thing is the hardware. And we all know that hardware, especially if we take a look 1 year ago, may not be as advanced as it is today. And there's also a little bit specifics in there. Georgia Tech was so kind to select a huge battery pack to go with that. We didn't select that one. So some of the stuff, there may be some learnings that are probably already there today that will change things. People were, when they used the Google Glass, they were sometimes confused a little bit with the swipe and the tap gestures. So you have to be careful what kind of interaction methods you use. But also bear in mind that these people didn't use it for a week or so and have the learning experience. It's really a short term. And even in that short term, Georgia Tech was doing some analysis, and really it got more fluent and more efficient already during that time. From the software point of view, one of the most challenging part was the voice part. And here it's also important to know a little bit about the surroundings. We didn't do it in an empty room. It was right on the production line, and
yeah, it's very noisy there. So you imagine there's these bands with the vehicles running back and forth, and then there's also these signals that people can pull a cord and basically request help if they have an issue with one of the assembly steps. But that triggers initially some music to play, so that people get notified to come and help. So at different distances, you have all sorts of music coming on at times. So it's really a noisy environment, and I must say this was an offline voice recognition, which did comparatively great. I was very surprised how well it did. But on the other hand, it still had some deficiencies, and for the person using it, it doesn't care that the technology is great. It's just, if I have to say something twice or 3 times, then that's it. I don't want to do that.
Yeah. So not the easiest environment to try it in, but certainly a realistic one. And of course, people expect the Siri at work also. Sometimes that's not possible. But I also believe that within the last year, there has been quite a big advances also in the voice recognition sense. In the process, there was also some stuff built in, to keep people awake in the process. There's sometimes defects they have to uncheck. So the system actually tells them there's a defect, and they have to realize it's not there. keep them awake in the process, but that sometimes can be cumbersome to some people.
Yeah, not so much the awake piece, but to really make sure that they check that and they actively say, oh, yes, I've seen this, and yes, this is okay. Right? So it should be awake anyway. But.
Yeah, but that's always the problem with the repetitive tasks to keep people really focused on the things. I mean, it's difficult to do that. Login takes too long. That's probably a little bit also associated with fit issues. They were scanning cards, the login cards, and they were also scanning certain numbers on the car. And with the Google Glass, you have to realize you have to not look at it straight. You have to look a little bit up or move your head a little bit down because the camera is located a little bit different. So I think these are things, if people use it a little bit longer, that will vanish. But in a short period of time, it's difficult for people to adjust to that. And on top of that, they had to wear certain kinds of protective glasses.
Safety glasses.
Yeah, and also some glasses with prescription. So in the worst case, they had 3 glasses on top of them. So that's probably not the ideal environment. But in that case, it was decided to do it in that way. On the upside, it clearly they loved having their information right in front of their eye, what they needed. They needed to have, I mean, they had it when they needed it. They weren't forced to go somewhere and find it when they did not need it. And it really made the process more fluent and convenient for them as well. And so in the long run, I mean, having the hands-free is always good. And at some of the stations, it's also important to have a flashlight to take a look underneath the car or something like that. So if you have your hands-free, that's quite essential for the process. Efficiency, it's faster, cutting down walking time. And what is also quite important, maybe it's not so much for the workers itself, but for the company, the accuracy went up. I mean, it's not surprising that if the normal process is you have to look at a list, you have to memorize the list, you go to the car, you do the checks, and you go back to the list and then report the defects, you're more likely to miss something. Or if you're like, oh, I'm not so sure, then maybe you leave it out, yeah? But if you do it right away with a smart glass on your nose, then there's no delay and it's very accurate.
And the bottom part is really, that's the bottom point, the check prompts, that's really for us, so that was the point why we did this project. And of course, it's always a bit iffy to tell people, well, we think that you may not be doing your job at times properly, you know. I mean, you know, who would like that, right, to hear that? But that was the original feedback from the associates, what they say themselves. You know, well, you know, at times, I probably missed something. So, you know, this helps me to do my job better.
So when we take a look at the learnings, or what we would also the hardware vendors to take a look a little bit, I think from all of our sides is rethink user interaction. And I think that has been talked about also yesterday a lot. We're still used to the mouse keyboard thing, and we're trying to apply the same thing to the wearable technologies, and it just does not work. And we as an integrator are often asked by a lot of customers, hey, we have this solution. Can we do a quick proof of concept and just port that on a smart glass and then have it running there? I'm not sure how often I got that. And it's very difficult to talk the people out of that because yes, we can do that, but it will not do you any good. The only outcome will be the technology sucks. That's what people will take out of it. And that's dangerous. So we usually refuse doing that. In certain ways, we need to, of course, go to the customer demand. And that's not so much BMW focused here. That's more of a broad sense from all the projects that we do, is in a lot of iterations that you would typically have in such a process, you usually get closer to what we originally suggested. But sometimes on the customer side, that also takes some effort. And also on the side of the hardware vendors, it needs to make sure that devices are intuitive to use with the gestures and things like that. You have gestures you can distinguish, things like that. And that's also from the hardware side, it's quite important. Voice recognition, key topic. I think that's one of the key interaction ways with wearables, especially with the smart glasses. Consuming information with the screen is so intuitive, and giving back feedback with voice is also so intuitive. There's often environments when that is difficult to do, so you need some kind of backup model also. But that's one of the key ways that has to work. And I think we all have to work on that to make that more efficient. And I know there's devices coming out with more microphones and better voice cancellation and so on. And that's going to be key to the process as well. Picture quality. I think this is something that's also important, to have a camera that has sufficient quality in terms of scanning barcodes. I mean, you can only, from a software side, only scan something you can actually take a picture of. So you need fast autofocus to focus on the barcode, and you need the sufficient quality. And for the defects, it's also important to have sufficient quality in the process. And maybe, I'm not so sure about that, but there's smart glasses coming out, like Brother has one. They don't have a built-in camera, but I think about having something mounted on top of it, like a webcam, which has a huge resolution. Maybe things like that will actually come into play. We have to see. Battery pack and also internal battery. I think the hardware vendors are also working on that. We are very much looking forward to the Vuzix M300, which is second battery right on the head. So we're looking forward to see what that is like with the hot swappability, things like that. These are things that need to be there to make it efficient.
Yeah, maybe the bottom ones real quick. There's also a bunch of internal things that need to be prepared, of course, if you want to use these new devices. You need to manage them. You need to make sure that the Wi-Fi is actually allowed. It's something that we're actually currently working still on. Backup solutions, what happens if they're not available, et cetera, et cetera. So there's quite a bit of homework that needs to be done before they can really be rolled out. And that's something that certainly can't be overlooked and needs to be accounted for.
I know we have to speed up here. To put that in the broad perspective, we were looking at quality assurance here, and just to give you some insight for me as an integrator of what we see of the demand and what our customers are looking for. In this case, we were looking at quality assurance, but we believe that the companies, they will start within one use case, one vertical, but they will want to expand. So they will be looking for solutions that can expand the whole value chain. So you might be starting with logistics, bringing parts to the assembly line. But once you have them on the assembly line, you want to have the information on how to put them together in the car in that sense. Then when you have the ready-to-go product, you want the same car information be integrated with a maintenance system. Know how to do maintenance. And if you're stuck at some kind of part in the process, you want to be able to call someone with a remote assistance functionality to get help and assistance. And we can see that all the customers are going into that direction, and we support them with the Wearable Computing Suite, where all these aspects are integrated. And BMW has a similar vision, looking into all of these different topics, so very innovative.
All right, so yeah, quickly summing up. I think bottom line, at least this is status 1 year ago, this was not ready for prime time. Not something that could be deployed for the various reasons that we discussed externally in terms of the technology not being where it needs to be, and then also not being prepared on the inside of the organization to really do this. Nevertheless, I think it's very important to really make steps like these pilots to gain that understanding, to see what is it that's missing, what do I need to pay attention for, and basically get the feet wet to then, once the technology is available, and I'm sure it will only be a very short time, that then we're ready as an organization to accept it and roll it out. And we do see certainly big benefits in terms of the issues around repetition, efficiency, and managing variability. And hopefully that will have, at the end of the day, the better product quality for hopefully all of you guys to enjoy in your new BMWs. Thank you very much.